Okay, so we're on to example 2 from the notes. So let's have a look at that. So example 2 is x squared plus 4xy equals 8. So um, x squared plus 4xy equals 8. So we're going to find the first derivative first. So take derivatives all the way through. Now, what I'm going to do is this constant multiplier here, the 4, I'm just going to move that out of the derivative. It will make it, I don't know, marginally easier, I suppose. So 4 times d by dx of xy. And you can probably see that's going to be a product rule problem. So this one here, d by dx, that will be 2x. D by dx of 8 is 0. And then we've got plus 4 times, and then the whole of the derivative of xy. So again, we'll call that u, call that v. And the product rule is v du by dx, so that's y times d by dx of x. Now that's going to be 1 plus u, that's x, dv by dx, so that's dy by dx. So now I want to isolate the dy by dx, so I'm just going to say, well, y times 1 is just y, so we can get rid of that. So now I take the 2x over, so I get 4 bracket y plus x dy by dx equals negative 2x. So then I want to take the 4 over. I'm heading towards the dy by dx, but it's trapped inside the brackets here, so I take the 4 over to untrap the brackets, so that will be y plus x dy by dx is minus 2 x over 4. Now that will cancel down to minus x over 2. Okay, so then I want to isolate the x dy by dx. The y goes over, and that gives us x dy by dx equals minus x over 2 minus y. Now, before I take the x over, what I'm going to do is I am going to turn that into a single fraction by cross multiplication. So remember that's y over 1. So I'm going to do that times that gives me minus x. That times that gives me minus 2y. And that times that gives me 2. And that means that when I take the x over, it can just go straight to the bottom line. Like that. And that's the first derivative. Now, if we have a look back at the problem, you can see there it is there, minus x plus 2y over 2x. I have left it as minus x minus 2, so I could factorize out that minus sign. Well, let's do it. X plus 2y over 2x. So that's basically the answer in the book. So now I'm going to find the second derivative. So let's write this down in detail. dy by dx is minus x plus 2y over 2x. So instead of using the quotient rule on this, I am going to take the 2x over to the other side. 2x dy by dx is minus x plus 2y. Oops. So now I'm going to apply the product rule to this. So let's do that. So u is going to be 2x and v is going to be dy by dx. And remember the product rule is v du by dx plus u dv by dx. So that's going to be v dy by dx du by dx is going to be the derivative of 2x. Now the derivative of 2x is 2. Yeah, plus u, so 2x, times the derivative of v. Now v was that, so the derivative of that is going to be d2y by dx squared, the second derivative. And now I want to take the derivative of this, but it's probably easier to take the derivative of it after I've multiplied them in negatives through. So I'm kind of reversing what I did earlier, just multiplying the negatives through. So the derivative of x is 1, so that's minus x over minus 1. And the derivative of 2y is 2 dy by dx. So now I need to isolate d2y by dx squared. It might be worth actually putting in dy by dx at this stage. We could put that in down there, replacing that. But it might be worth just tidying it up a wee bit before we do that. So what I'm going to do is I'm going to take that over to this side because I want to isolate the d2y by dx out. So 2x d2y by dx squared. It's negative 1 minus 2 dy by dx minus 2 dy by dx. So that comes out as minus 1 minus 4 dy by dx. Okay. So minus 2 is minus 4. And now I'll copy in dy by dx. So dy by dx is negative x plus 2y over 2x. So now I've got negative 1. Now that negative multiplies by that negative to make 4. Sorry, plus 4 rather. So that'll be x plus 2y over 2x. And I've not bothered putting these brackets in because I've taken the negative away, so they're no longer required. And then the 4 and the 2 cancel, leaving 2. That's minus 1, 2x plus 2y over x. Sorry, missed out the plus there. And we've got 2x d2y by dx, 2x d2y by dx squared. Now, I'm going to take that 2x over, but it probably makes sense to turn this into a single fraction first. So I'm going to do it by cross multiplication. So I've got that divided by 1, and then this divided by this are the sort of cross multiplication components. So this times this is going to be minus x. This times this is going to be 2x plus 2y over this times this x. So now I can take the 2x over. That goes straight to the bottom line. So minus x plus 2x plus 2y over 2xx, so that's 2x squared. And now I want to do a bit of simplification. So here, I've got minus x, multiply the brackets, that's going to give me 2x, and that's going to give me plus 4y over 2x squared. And these are now like types, so I'll get rid of that. So minus x plus 2x is x plus 4y 2x squared. Now, my next question is, can I simplify that based on the original problem? So I'll go all the way back up to the original problem. It was x squared plus 4xy equals 8. X squared plus 4xy equals 8. Now, it doesn't look particularly like that's going to get, it's going to appear in there. But actually it does. It's not entirely obvious. If I factorize out x here, I get x plus 4y equals 8. There, that x plus 4y, that's that thing there. So in order to work out what the simplification is, I take the x over. So x plus 4y equals 8 over x. And now I can put that into there. So I get 8 over x times 1 over 2x squared. So the 2x squared is still in the bottom line. And I've replaced that with 8 over x. That comes out as 8 over 2x cubed. And that's the final answer. So, whew, that's quite long. So let's zoom out and have a quick look. And again, you can see it's very long. And that's typical of the working for these problems. It's usually a couple of A4 sheets, or sheet and a half anyway. So if we zoom back into that, let's have a look through. So we start with the basic problem and we apply product rule and isolate dy by dx. So we get down to here, that's dy by dx. Then I take the 2x from the bottom line over to make this a product rule problem. Leave that behind. Differentiate all the way through. Then I substitute back in dy by dx from there. Now I could have substituted it in here and here, or here and here, but having one instance of it makes it slightly easier, I think. And the rest of it is just tidy up to get to a point where I could spot the back substitution from the original problem. And really, it's not obvious. It just requires experience to see how to tackle this one. And you can see down there, simplified. So let's roll our way down. And you can see down there. Now, the way this person has done the algebra is slightly different from me. And also, they haven't back substituted the original problem. So it leaves it short of its maximal simplicity. Okay, so the next video we'll have a look at example 3.